Where's my sound? Where's my sound? Okay, what's happening? Headphones. All right, guys. Okay, so welcome. Just got to do a couple of things here. I've got a couple of new gear, so testing it out. Give me 1 second. That's too loud. Good, Daniel. It's been a while, man. It's been a while. Okay, guys. So it is 7:30. We are going to get started. So what I wanted to kind of talk to you guys real quickly is I've been kind of playing around with Google Sites, and just to make things a little bit easy for you guys, what I've actually done is I've indexed all the questions. Now, if you already know this, I'm sorry, I'm just going to show you guys where it is. So on in my YouTube channel, and you should be able to access this whether it's on the web page, but I've also put it on I've also put it in the description in this particular video as well. So there should be a link to my website, and if you go into my website, because we're doing level 2 at the moment, so just click on level 2 and go into Algebra, and under Algebra I've got live tutorials. So every time I do a tutorial, those tutorials will actually go up here. And so some of the past tutorials from previous years are actually there as well. So like last year when I did tutorials from 2019, and also a couple of tutorials from 2018, that's there. All right, and one more thing that'll be useful for you guys is if you go into NCEA exams, and what I've actually done with the NCEA exams is I've put a one-stop shop for you guys. So you can go into, so if you're working on past exam paper questions, then you should be able to just go into 2019, for example, and all the questions are actually indexed there for you guys. And this is for the, I think I've done it up to 2015. So yeah, so that's all available for you guys. All right, so the link to this website is actually in the description of this video. So you guys can actually pick it up from there, and just, yeah. And one other thing I was going to tell you guys is please feel free to share this to anybody that you can, because I know that there's a lot of guys that actually find this really at the last minute and then kind of worry or stress about it, that they wish that they actually found it a bit earlier. So if you could share it, I'd really appreciate it as well. Cool. So in terms of what I'm going to be working on, I've also put a link on the description calling notes. So in this current video, you should see some notes, and the notes should take you to the whiteboard where I'll be actually doing all the work for today. So for example, if you open up that notes link, it should take you to a OneNote that looks similar like this, but it'll be on the web page, on a web page. And if you guys go into level 2 algebra tutorials, so this is tutorial 1, what I might do is I might just put the date there, today's date there, so that you guys can know that this is where you need to go if you want to have a look at the questions before you come to the tutorial. And that way you kind of know whether this tutorial is useful for you or not. But all the stuff is going to be available for you guys offline anyway. So when I finish it, this document is live. So you can actually follow this link and just kind of work through the questions at an earlier pace if you want. Okay, so that's all the jargon soon. Yes, Science Sigo, I will be sorting it out. I think I've got something tomorrow. If it goes well, then I'll basically chuck back the level 1 tutorial. Quick questions on the sidelines here. Where am I from? New Zealand. I'm from Auckland. Chris, you're solving. Okay, sweet. Okay, so guys, so the first lot of questions that I want to have a look at today is simplifying with positive indices. So that is these three types of questions here. And then after that, we're going to go for solving for x. So we're going to be looking at using logs. You could use logs, and then you can actually use some tricks with rearranging the powers as well. So that's something that we're going to be doing. So we got a few questions like that, and also with surds, so how to actually work around with surds. And then finally we'll finish off with these last two questions, which is make x the subject. Okay, so how I normally do these things is that even with tutorials is I try and go through a question with you guys, but as always I'm going to give you guys like a couple of minutes to try these questions, and then I'll actually go through them. Now, even if you don't know how to do these questions right now, you haven't actually done algebra yet, just have a go at it, right? Because even if it's completely wrong, no one's looking, all right? And then when I go through the answer, you're going to actually figure out where your mistake was, and you're going to learn much faster. All right, so in saying that, I'm going to give you guys I think we've got about 3 questions here, so I'm going to give you guys about a minute for that, not a minute, 30 seconds for that first question. So have a go at it, and then I'll start going through each of these questions one at a time. All right, and now if you do finish the questions, guys, feel free to chuck the answers up there, and I will kind of go through them slowly. All right. Yeah, I think that's more than enough time there, guys, for the first one. So I'm going to go through the first one here. So with the first question, remember that you've got a -3 and you want to change that to a +3. So if you want to change that to a +3, then what you need to do is you need to rewrite this as 3 divided by 2x to the power of 3. So once we do that, then just remember that the 3 is actually, it's raised to the power for the 2x. Now the 2 has a power of 1 and x has a power of 1. And because of that, we rewrite this as 3 divided by 2 to the power of 3 and x to the power of 3, which means we're going to get 3 divided by 8x cubed. All right, let's have a look at the second question, 1b, and I'll give you guys again about 30-40 seconds to give it a go. All right, guys, going to go through 1b right now. So whenever you're dealing with a fraction, and this is a really neat little trick to actually have, when you have a fraction and a negative, when it's raised to a negative power, what you can literally do is you change the power to a positive and flip the fraction upside down. All right, so in other words, all I'm going to do is I'm going to rewrite this as 3y squared divided by 4x cubed, and that's now raised to the power of 2. Okay, once that's done, just remember once again, this is where people actually forget about that 3 has a power of 1 and 4 has a power of 1. So that means you're going to get 3 to the power of 1 times 2 y to the power of 2 times 2, and in the denominator you've got 4 to the power of 1 times 2 and x to the power of 3 times 2. Now of course this simplifies as 3 to the power of 2 is 9, and then you've got y to the power of 4, and of course that's divided by 4 squared, which is 16, and we've got x to the power of 6. Now I know in some of the SynCos papers this comes out as a merit question, and I know that also in NZQA paper it came out as a merit question a couple of years ago, but I doubt they're gonna bring, like, I didn't see it I don't remember seeing it last year. Let me just have a quick look. I don't remember it off the top of my head seeing a question like that. Not with power indices anyway. Oh no, there was one. There you go. It was actually an achieved question. It was a merit question before, but I guess they've kind of changed it, dialed it back now to an achieved question. Alright, so anyway, back to this part here. Let's go to question 1C. I'm going to give you guys, as usual, give you guys another couple of minutes and then I'll go through it. But I'll also leave the other kind of questions popping up. So guys, with 1C here, 2A is 1.79. Oh, right, you're right. Okay, so with 1C, we've got 3 to the power of 2 as a power. So what I'm going to do is I'm going to put down 64 to the power of 1. And Zainab, what you want to do is you want to simplify that further. So you're right, but you can actually simplify it further, Zainab. Alright, so what we got is 64 to the power of 1 times 3 over 2, p to the power of 6 times 3 over 2, divided by p to the power of 10 times 3 over 2. Now, 64 to the power of 3 over 2, again, you can actually use a calculator in this case. So just make sure you have brackets around the 3 over 2. Alright, so we've got 512. So we can put that as 512. P to the power of 6 times 3 is 18. 18 over 2 is 9, divided by p to the power of 15. But we do need to simplify this further. So, and because if we look at the powers here, 9 in the numerator, 15 in the denominator, we can rewrite this as 512 over p to the power of 6. I'll be happy with question 1A, B, C. If you guys are happy, then we can actually move on to question 2 and finding x's. Bryn, just keep an eye on Instagram socials, man. I'll just need to work out a few things and then I'll get back to you guys. You're happy, Daniel? Yeah, I know you're happy because you've done this before. Shot. Okay, so that's 2. Okay, so then we'll go to question 2. Alright, so question 2A, we've got 4 to the power of x equals 12. Any tips in terms of studying for the NCEA level 1 and CAT? Campbell Jones, go to my website, go to level 1 Algebra, and have a look through. There's skills, there's tutorials, there's exam revision material, and there's like prep questions. There's heaps of material there for you to go through, man. You go through that, you definitely got to get a merit at least. All right, but you do a little bit more hard work, I'm sure you can get an excellence. All right, guys. Now with question, what do we call it? Question 2. I'm going to show you guys. I'm going to show you guys a couple of ideas here, just to make things a little bit easy for you. One is you can actually use your graphics calculator to solve these things. All right. So all of these 3 questions that I put here, you can actually use your graphics calculator to solve it. But in saying that, just learning how to use the logs is definitely a lot easier. Not a lot easier. It'll be useful for you if you're planning to carry on with maths later on. Okay. So to do this, what you want to do is go into menu, go into equation, and click on solver. So solver is the one that says F3. So click on solver, and then you literally just type in the equation. So you got 4 to the power of x, and your equals button is shift the decimal point, and you put in 12, click enter, and click on solve, which is that F6 button. And there's my answer right there for 2a, which is 1.79. So the thing though is with these questions, it's really important to remember that they want to you to show some sort of working. All right, and because of that, it's a good idea to kind of learn how to do this. So you can actually use logs or ln in this case, it doesn't matter. So I'm going to show you guys both. So if I take log 4x equals log of 12, then according to the log rules, I can bring x to the front, and I can rewrite this as x log 4 equals log 12, and then x is equal to log 12 divided by log 4. So we know the answer is 1.79, but if we go into just the main menu there, so we're going to do log 12 divided by log 4, we're going to get 1.79. Now you can still use ln as well, so you can actually go ln of 12 divided by ln of 4. That's also going to give you the same answer. But what you can't do is you can't actually go log of 12. You can't mix them up. So you can't actually go something like this. You can't go log 12 divided by ln of 4. That won't work. That won't give you guys the right answer. So just keep that in mind. So you can actually use logs, or you can use ln, but if you use one, just make sure you use the same one for everything. Cool, so that's 1.79 for this. We are going to keep powering through this at the moment by the looks of it. 2b, we've got 3x minus 1 equals 10. So what do we've got? We've got a couple of different answers, or is it the same answer? 1.09. Right, we got a couple of different answers for 2b. Or do I only see one answer? No, I see 2 answers. Okay, let's find out what's happening with 2b. We're going to take logs, but this time let me just use ln. So I'm going to go ln of 3x minus 1 equals ln of 10. Now remember that the power comes to the front, and it's the whole power. All right, that means x minus 1, the whole thing comes to the front. So we're going to rewrite this as x minus 1 times ln of 3 equals ln of 10. We're going to get rid of the ln of 3 to the other side, and it's going to become divided by ln of 3. So we're going to end up with x minus 1 equals ln of 10 divided by ln of 3. So what do we got? Log 10 divided by log 3. Have I made a mistake here somewhere? No, I know what I've made a mistake. Hang on, let me try that. ln of 10. I thought something looked a bit weird. ln of 10 divided by ln of 3. Here we go. So I got 2.09. Where did I get 2.09? Yeah, let's just leave it at that, 2.09. So that means x is equal to 2.09 plus 1, which is going to give me 3.09. Yeah, just going back to your guys' question about whether algebra is easier or calculus is easier. From kind of my experience, I've seen that calculus is slightly easier. Michael, yes, you can use logs. I think, as I was talking earlier, you will still get the same answer. So if you actually go log 10 divided by log 3, as you can see, you're still going to get the same answer. Bryn, I don't know, I don't have time for this, man, so take a time out, buddy. Okay, all right, so we are okay with 2b. Going on to 2c, guys. Now, how many of you guys used a calculator, not a calculator, how many of you used logs for 2c? Damn, that means you guys would have actually seen some of my tricks then. Okay, so that's all right. Then I'll just go through this real quickly. Okay, Angelica. So the way you can kind of do these two questions, 2c and 2d, is this. What you're trying to do is you're trying to get x by itself at the end, right? So because you're trying to get x by itself at the end, you've got to actually get rid of this 5, the power 5. So to get rid of the power 5, what you can do is multiply by 1 over 5. And if you do that on one side, remember that 50 has a power of 1. So that means you've also got to multiply the power on the other side by 1 over 5. Lethan, it stands for natural log. So it's just another version of log. So you can use log or natural log. It doesn't matter. You'll still end up with the same word. No worries, Harrison. Let's keep going, man. So at this point, because 5 times 1 over 5 is just x to the power of 1, we can just leave it like this. And the answer here is going to be 50 to the power of 1 over 5. So work that out, and then you've got that answer. So I'm going to go 50 to the power of 1 over 5. Just make sure that 1 over 5 is inside a bracket. And so you should be getting 2.18. 19. There we go, 2.19. So if that's the case, you guys should be able to look at question 2D and pretty much follow that same idea now. All right, because what we have is x to the power of 3 over 5, and we want to get rid of 3 over 5. So what we're going to do is multiply by 5 over 3, the power anyway. And remember that 10 has a power of 1, and so we're going to multiply the power by 5 over 3. So when we do this, we're going to have x by itself, because 3/5 times 5/3 is just 1, and then you've got 10 to the power of 5 over 3, which means x is now equal to, this is interesting, so 10 to the power of 5 over 3. I got 46.14. I did not see that answer, did I? Did anybody put that answer up there? Yeah, 46.42. We're happy with that. Sweet. Let's leave it at that. Are you guys okay with that? Do you feel like you need another question? I'll see Rahul. It might be tomorrow, Sunday for sure. All right, you know what? Let's do another quick one here for 2D, but I'm going to extend it out for you guys. So let's call it 2D part 2. Oh, actually, wait. Before I do that, I'm gonna give you guys another one of those soon. But can we just try 2e first, and then I'll give you guys an extension of questions 2d and 2e together. Mochi, I think we all have school tomorrow. Ah, the academic counseling. Oh yes, I remember those. Okay guys, 2e, how are we going? Irrational and whole power. We're gonna cover that triple L. You got 3125. 3125. Okay, so let's figure out how to do that, all right? So when you guys get, when you're dealing with surds, or when I'm talking about the square root symbols here, the first step is to do this. Rewrite this as x to the power of 2 divided by 5. And that's equal to 25. That's pretty much what you got to do for this first step of this question. And once you do that, then everything else becomes really easy, because the next step is you go, well, I want to get rid of that 2/5, so I'm going to multiply by 5 over 2, and then I want to also do the same thing. 25 has a power of 1, and I'm going to multiply by 5 over 2. So I end up with x is equal to 25 to the power of 5 over 2. So chuck that in the calculator. 25 to the power of 5 over 2, and I got 3125. Yeah, so guys, like, you can actually use logs and natural logs for this. It requires you to do an extra step, but I think I did this back in when was it, like back in when lockdown started. We were doing a lot of questions like this. So it's really important to understand that, like, this little trick that you have with the inverse of the power works really well when you're doing those questions with those word questions, especially those word questions where, like, somebody buys a house and, like, you know, invests it for this long. It just becomes so much more easier when you learn this little trick. All right, so I'm going to give you guys one more question like this, and I'm going to slightly modify it. Yeah, we went through it fairly quickly, but I think we did do most of the work in all honesty, Mochi, so should have been all right. Okay, so you guys try this question here. Not Beckhamster. It's like you have to do like a double version of logs. Like, what I'll show you how to do that question 2D, but I'm just going to leave the 2f here so people can try it. So 2D was x to the power of 3 over 5 equals 10. I think, was it x to the power of 3 over 5 equals 10? Yeah. So the way to use this with logs is that you would need to do something like this first. I'll actually use logs so that you can kind of see it. So you've got log of x to the power of 3 over 5 equals log of 10. Then you bring the power to the front. So this becomes 3 over 5 log x equals log 10. Then you have log x equals log 10 divided by 3 over 5. So you've actually got to work that out first. So I'm going to get log of 10 divided by 3 over 5. which equals 1.6667, whatever. So we've got log x equals 1.6667, then x is equal to 10 to the power of 1.667. So if I go 10 to the power of, and I actually end up with 46.41. So Beckhamster, as you can see, it is like, how many steps have we got? 1, 2, 3, 4, 5, 6 steps if you take logs. But if you do that inverse power thing, it's literally in 3 steps you can actually get it done. So Mochi, remember that any number by itself has a power of 1. So that means this is x to the power of 1. Yeah, Beckhamster, that's why I try and, I mean, you can know it. If you know it, it's alright. But then if you understand how powers work, you don't actually need to do all of those things anyway. So, yep, Triple L, you're on the right track. 2F, we've got a couple of answers. We've got 11.96 and we've got 19.19. Let's have a look. So the first step I'm going to do is I'm going to rewrite this as x to the power of 2/3 multiplied by x to the power of quarter equals 15. Now I got to combine the two powers, so remember that this then becomes 2/3 plus 1/4 equals 15. I'm just going to be super lazy in this. What have we got? 2/3 plus 1/4, 11 over 12 equals 15, and then x is equal to 11 over 12 multiplied by 12 over 11, and of course 15 has a power of 1, and that gets also multiplied by 12 over 11. So we've got x is equal to 15 to the power of 12 over 11, which means we can figure out what this is now. $19.19. Wonder how you got 20.1. Could be a mistake with the fractions. Triple L. 1 over 0.9. I think that didn't make sense as well. Yeah, no worries, Lethan. I'm here till November, mate. Okay, guys, another one like this. Are we happy to move on? Sweet. Let's move on then. This next part of this series is probably one of my favorite set of questions. It always throws people off, but we'll probably spend a bit of time in this rearranging questions, guys, so don't stress about it. But we will be doing it with the powers anyway. So these are the two questions that I've set up for you guys here. And what I want you guys to do is make x the subject. So I'm going to give you guys about a good time for it. Like, I'll give you guys about a couple of minutes for this. And I'll start working on it. While you guys are working on it, I'll actually need to look for a few more questions like this. Glad to hear, Jason. 15 over 3p plus 4. Ooh, 3p minus 4. Look at that. Definitely controversial. We got 2 plus 4s and 1 minus 4. Layton, I don't actually teach senior subjects anymore. I walked away from senior college last year and moved to junior college. Unfortunately, it doesn't work like that, not Beckhamston. Unfinished 1.33. Why are you at 1.33? Alright guys, I'm going to go through this first question and I'll throw a few more questions like this. So the first step obviously is to get rid of the 8 and the 16. Now we know that these are powers, right? And because, whoa, yeah, now that's going to kill you there, Angelica, if you try to do it that way. Yeah, I think you're in some serious problems there, Angelica. So what you needed to do was this. Remember these questions that we did in level 1 where, yeah, that what Triple L is talking about with the 2 to the power of 3 equals to 8 and 2 to the power of 4 equals 16. That's what you need to do the first step, because and that's really important that you guys notice these numbers, all right? If you see the numbers 8 and 16, or even in question B, you can kind of see it. Question B, you've got 9 and 27. Those are familiar numbers for you guys because you can replace it with something 2 to the power of something or 3 to the power of something. So what I'm going to do is I'm going to replace 8 with 2 cubed and 16 with 2 to the power of 4. And now all of this is actually raised to the power of px minus 1 equals 2 to the power of 4, 3 minus x. So at this point, what I need to do is I need to multiply the powers. All right, or I could actually rewrite it like this. I could actually rewrite this as 2 to the power of 3. This was p actually, multiplied by px minus 1 equals 2 to the power of 4 multiplied by 3 minus x. I'll just hang around there, like, let me know if you guys get what I've just done there, because if you don't understand that part, then it'll be, yeah, it's kind of pointless. So let me know if you're good with those, what I've just done so far in that third line. We'll mix it up, Eva, so we'll do like algebra and then we'll do a bit of calculus, and then that should give us enough time to actually, by the time we get to November. Sweet. So once that's done, what we can then say is, because the base is 2 and the base is also 2, that means the power has to equal the other power as well. Because we've got something like 2 to the power of something equals 2 to the power of something, and those two somethings are colored in pink, which means they're equal to each other, we can rewrite this as 3 px minus 1 equals 4 3 minus x. And at this point, what we need to do is expand the brackets and we need to rearrange. So we're going to get 3px minus 3 equals 12 minus 4x. Now we want to collect all the x's on one side and numbers on the other side. So we're going to rewrite this as 3px. Negative 4x when it comes to this side becomes plus 4x, and negative 3 when it goes to the other side becomes plus 3. And on the left hand side I've got x as a common factor, so I'm going to take it out. I'm going to get x is equal to 3p plus 4 equals 15. And then of course now I can get rid of the 3p plus 4, so I'm going to get 15 divided by 3p plus 4. So yeah, I think we had a 3p minus 4 in there. Yeah, Mochi, that's algebra. You gotta do that. Leon, definitely. I don't know, man. Like, and I know, in like sometimes I've seen it pop up as an excellence question, but knowing these guys, they might actually just put it as merit. It'll definitely be a merit or an excellence question, Leon. Yeah, I just realized that question 3b is so easy, like straight up. Like, I didn't realize I was supposed to put an x on the other side. I forgot. That's my bad. That's alright. We will do question 3b real quickly. Actually, before I do that, any questions with 3a, guys? Any part of the lines that you guys didn't understand, just yell it out. So line 1, 2, 3, 4. Yeah, it is unpredictable. Are we good with this question? Can we go to question 3b? What happened on line 2 and line 5? Okay, so with line 2, I kind of will show you guys this. So remember that when we have something like this, x to the power of 3 to the power of 4, we can rewrite this as x to the power of 3 times 4. So that's all I've done here. So all I've done is just gonna get this highlighted part for now. So I've taken the 4 here, and that's actually gets multiplied by the 3 minus x, like how it happens here in this idea. So that's pretty much what happened in line 2. Let me know if that's okay, Harrison. Line 5. In line 5 I actually wanted to bring all the x's to the one side, so I actually brought 4x to this side, and I took minus 3 to the opposite side. So Lethan, all I did, Lethan, there was just to bring all the x's, the unknowns, the x's onto the left hand side and shift all the numbers to the other side. Sweet. I think we're good, so we will go to 3b. So 3b, what we have is this. We're going to replace 9 with 3 squared to the power of x over p minus 2q. 3 to the power of 3 as 27, and that's to the power of q. So straight away you guys can see what's happening here, right? Like, who was it that was asking? Harrison. If you look at that line 2, what we did before, we're going to do the power multiplied by the outside power. So we're going to rewrite this as 3 to the power of 2 multiplied by x over p minus 2q equals, and we're going to get 3 to the power of 3 times q is just 3q. So now, because the two powers are the same, the bases are the same, we can get rid of the two bases and just write the powers by themselves. So we're going to get 2x over p minus 2q equals 3q. So at this point, we want to actually expand the bracket. So when we expand the bracket, we're going to get 2 x over p minus 4q equals 3q. Then we've got 2x over p equals 3q. And when I shift the minus 4q to the other side, it becomes plus 4q. And I've got 2x over p equals 7q. Cross multiplication, so 2x is equal to 7pq. And then x is equal to 7pq divided by 2 or 3.5, doesn't matter. Oh, thanks, Nate. I think that's why I left senior school. I just needed a break. But it's actually nice doing this stuff without having the pressure of marking all of this stuff. Does the order of P and Q on last line of 3B? No, it doesn't matter. You can write it as 7QP. But it's just in algebra, we always write in the alphabetical order. So, but you won't get marked wrong if you write 7QP over 2. I don't think you even get marked wrong if you write QP7, for example. Alright guys, I'm gonna try and find a quick question because I think we only got time, we only got another 10 minutes. Do you guys want me to find like a really old question, an excellence question from the old papers? I can modify it real quickly, so just give me 1 second. Because I think it was 2016 maybe, this rearranging question, I saw one. No, that's not it. Thought it was 2016, maybe got 2014. Go right back. Distinct roots. Oh, this is an interesting one. Okay, all right, let's try this question here. Okay, I'm not actually going to tell you guys what this is, but I think you should be able to do this question. What do we have? Maybe not. Yeah, let's do that. Yeah, it's a nice question to finish off on. It's actually quite a horrible question, to be honest, but it'll make you think. So you're solving for x, not rearranging. You're trying to figure out what x is. That's good, Mochi. It's a nice question actually, because it actually covers pretty much everything we've done today. So you got to use all the skills we've learned, well, all the type of questions that we did today. What do you got, Joseph? 4/9 to the power of x. Now, Joseph, if you use the graphics calculator, you got to show the working. Okay, Angelica, you got 0.93. 0.93. Wow, yes, awesome. We got two different answers already. So here's the thing, if you know that you know what your answer in the graphics calculator is, then it's just a matter of you trying to figure it out now. So have a play around with it. This is the last question, guys, we're going to be doing today. Two over 3 to the power of 2x. Oh, that's interesting. Nice. Finish it off, Nate. Finish it off. Nate, try and get rid of that. Instead of writing it as to the power of 2x, try writing it as to the power of x, and you should be done after that. We got negative answers. Interesting. Daniel, I think it's because of rounding errors, man. But what I'm fascinated by is the fact that we've got positive answers and negative answers. All right, let's actually do this. Now, this question here, folks, I'm not going to lie. There is so many ways of doing this. I'm going to show you guys at least two different ways of how I see this question. All right, now you might have done this completely different. That's absolutely fine. But I'm going to show you guys a few methods. So the first method is this. All right, notice how. So this is the first method. Let's get rid of this. You've got 4 to the power of x times 3 to the power of negative 2x equals to 10, right? Now, the thing that I notice is that x is a power in both of these two terms. That means I can do something like this. 4 to the power of 1 times 3 to the power of negative 2 to the power of x. Would you guys agree with that? Sorry, I'm just getting rid of a couple of things here. Because if you think about it, okay, yeah, you guys are agreeing. That's good, that's good. Because think about it, because 1 times x is x, and then negative 2 times x is negative 2x. Now, if that's the case, you've got 4 times 3 to the power of negative 2, which is the same thing as saying 4 over 3 squared to the power of x equals 10, which means you got 4 over 9 to the power of x equals to 10. And I think that's what I was talking to about Nate when he did that. Nate actually did 2 over 3 to the power of 2x. So Nate, when you actually bring that 2 inside the power 2, 2 squared will become 4, 3 squared will become 9, and then you get 4 over 9x. Now what we do is we take log. So we got log of 4 over 9x equals 10. Bring the x to the front. Which means we're going to get x is equal to, forgot the log here. So we're going to get x log 4 over 9 equals log 10, and then x is equal to log 10 divided by log 4 over 9. So then x is equal to, let's see what happens, log 10 divided by log of 4 divided by 9. So our answer should be negative 2.83. Can't seem to get rid of that. There we go. So that was the first method that I did, right? The second method that you could have done, Joseph, what are we talking about? Like negative 2 point, as long as you're getting somewhere close to it, man, you should be all right. Oh, I think you might be right there. I didn't check it properly. Yeah, 2.84, sorry. It should be 2.84. I was just too lazy, my bad. Mochi, is that a good thing? You understand it or you don't understand it? Leon? Yep, sure thing. So, because if I look at that 4 to the power of 1 times 3 to the power of negative 2, right? Now remember, when it's 3 to the power of negative 2, this could be written as 1 over 3 squared. So we're going to get 4 to the power of 1 times 1 over 3 squared. Which means we're going to end up with 4 over 3 squared, which is what we got right here. So anytime, Leon, there's a negative power, you can bring that term down to the denominator or switch it over. Like if it's in the numerator, you bring it to the denominator. Converting it to base 3, I would say yes, it's a bit complicated because you're going to end up with like a real weird decimal in the power Estelle. All right, I want to show you guys the other method that I was thinking, which kind of follows the same principle really, because what I've got here is I've got 4x times 3 to the power of negative 2x equals to 10. So I can rewrite this as 4x to the power divided by 3 to the power of 2x equals 10. Mochi, I think that's what algebra does most of the time to you, is that you get these questions where that first part is going to throw you off, and then after that it's like pretty much easy. Alright, so the second way that I was thinking was from here, because x is in the numerator and denominator, I can rewrite this as 4 over 3 squared x equals to 10. Basically, I start following this part from here. So Estella, if you were trying to do to the base 3, then you'll have to have 3 to the power of something that equals to 4. And it's gonna... You can still do it. It's not complicated. You can still do it. It'll still work. Because you guys got a graphics calculator, it should still work. Yeah, like I said, Mochi, like, you know, you got a couple of ways of actually doing this. So I think, I'm trying to think if there's any other way of doing this. Off the top of my head, I can't think of anything else. All right, guys, any other questions with 3C so far? Are we happy with it? Let me check, man. This was from like 2014 3B. Let me find out. Give me 1 second to find out what this question was. 2014 3B. 3B is an excellence question. Yeah, this last 3C, yeah, for us this question would be an excellence one. Written in log form. So basically getting that first step will get you an achieved, and then writing it in log form gets you a merit. Finding the X will get you an excellence. Yeah, but you see, I mean, the problem is it's that first thing, right? I think once you figure that out, it's like the rest of it just becomes easy. So, okay, team. That's us, guys, for today. So what I really wanted to ask you guys is like, because I know that some people haven't actually started. Is there like a cheat way to do this in graphics calculator? You can get the answer in the graphics calculator, but you can't. Hang on, let me just show you guys. Yeah, you can actually do it in the get the answer in graphics calculator, but the problem is for this question, they would want you to show it in logs. If you just write the answer by itself, you probably won't even get an achieved, because you haven't actually done the criteria for achieved. All right, so that's why the calculator is there for you to check the answers, but really you want to be able to show the working. Next up, guys, I've got a level 1 tutorial coming up next, and I guess the quick question I wanted to ask you guys before people left here is, do we want to cover algebra next or calculus next? Because I know some people haven't started calculus yet, that's why I don't want to go into it yet. No worries, Mochi. Algebra. Don't worry, I'll put it up on Instagram just to see what we're getting, because I was thinking of exam questions. If people are just starting calculus, then I don't want to confuse with the exam things. So we'll finish off, we'll do a few more questions with algebra, and then we'll come back to calculus. So we've got time, we've got plenty of time. All right, guys, that's me. I will catch you guys later. As always, I'll stop the stream and just hang around. If you have any questions, feel free to ask. And yeah, thanks for joining, and I'll catch you next time. Keep an eye out on Instagram to figure out when the next tutorials are on. See you later, guys.